You can ask away. Okay, so this is in your math book, Chapter 1, Section 5, and we're talking about greatest common factors, or GCF. And you'll see GCF a lot. That's what it means, greatest common factor. You're looking for the largest number between two or maybe even three numbers that will go into them evenly. So I could start with something simple here. Now, I think most of you remember the Venn diagram that we did the other day. And so if you're talking about numbers as opposed to the two girls that we had in front of the class, and we were looking how they're similar and how they're different, when we're talking about numbers, it's kind of the same thing. If we have two numbers, maybe one number will have just certain numbers that will go into it, and another number might just have certain numbers that would go into it. But they both have sometimes numbers that would evenly go into, both of them. So, I could do something simple here. How about 10 and 25? So I could factor out 10, and that's going to be 2 and 5. So there's the factors of 10. I could just list them, 2, 5. Now I need to do 25, and that would be 5 times 5. So the greatest common factor between them is a 5. Now, when the numbers are the same, like in this case here, you pick the number that is the smallest, because sometimes they'll have an exponent, like this is 5 squared is 25. Well, 25 obviously is not going to fit into 10. So in this case, and it's pretty obvious to most of you, that the greatest common factor is 5. 5 goes into 10, and 5 goes evenly into 25. All right? Let's do one that's a little bit harder, a little more complicated. And I'm looking on page 30, and I'm looking at A here, and it's 36 and 48. All right? Well, 36, there's different ways you could do these, but they all, if you do it correctly, they all end up with the same number of factors. I'm thinking 3 and 12. And then 12 could be 2 and 6, and then 2 and 3. So now we look at the factors. We've got a 3, we've got a 2, we've got a 2, and we got a 3. And if you have a comment, raise your hand. Thank you. So we have 2 2s, so that's 2 squared times, and we have 2 3s, 3 squared. Now we'll do 48. 48, we could do 4 and 12, and we can divide 4 further up, Mr. Salcedo, 2 and 2, and we can divide 12 up, which would be, I could do 2 and 6, and then I could do 2 and 3. So how many 2's do we have in that? 1, 2, 3, 4. So it's going to be 2, I heard somebody say it, 2 to the what?
4 times 3.
2 to the 4th times 3. All right? Now, here we have some factors that are the same, and they both have exponents. Which one has the smaller exponent?
The first one.
Yeah, the first one, that's 2 squared. What is 2 squared?
4.
4. Okay. And they both have 3's, right? You can see those there.
Would not be the greatest.
Which one has the smallest exponent?
The second one. Right.
Yeah, the second one. And just so you guys know, all numbers, and we don't put them down, if I wrote the number, I don't know, let's say 17, there's an assumed exponent of 1 by that. Any number you write, and we don't put it down, all whole numbers have an exponent of 1. So, I mean, I could say there's an exponent of 1 right there. I just don't write it. But which one has the smaller exponent? Well, just the 3 by itself. So I put down the 3. What's 4 times 3? 12. So the greatest common factor between 36 and 48 is 12. That's the largest number that will go into both numbers evenly. That's what we're looking for. That's what the greatest common factor is. We're looking for the largest number that will go into both numbers evenly. All right? Now, and I'm showing you this way because I just taught you how to factor numbers. There are other ways to do this, and your book shows you some other ways. And one of the ways is this right here. Okay? What they do, it says find the greatest common factor of 24 and 40. Here's what they do. Look at this. They just list the factors of 24. And then they just list the factors of 40. And then notice that both numbers have a 1, both numbers have a 2, both have a 4, and both have an 8. So what's the greatest common factor between those two? 8. So that's another way you could do this.
It's just easier to do it like when you're able to break it down like that.
Well, it's, and whatever way is easier for you guys is the way you can do it. So it's up to you. It's up to you how you do this. You can factor it out or just list the factors. And again, you can flip back in your book in this particular section, and it gives you examples of doing that. So let's look at some problems together here. Let me see here. Looking to see what page that's on.
It's on page 92.
Let's look at number 2 right here. So I'm looking at this one right here. And it says 18 and 72. All right, so again, you could list the factors of each one or do the prime factorization, which is, it's kind of the method I prefer. So let's do 18 first. Let me pull a stick here. Looking for 2 numbers. Miss Sensor, what are 2 numbers that would go into 18? 2 times what equals 18? Look at your chart if you need to.
9.
Yep, 2 times 9 is 18. Nicely done. Put up 10 points. Miss Gossage, can I break down the 2 any further? No. How about the 9?
Yeah.
What would it be? 3 and 3. Nicely done. Put up 10 points. So 18 is 2 times 3 squared. All right. Now we're going to do 72. I'll do the first one. Well, it ends in an even number, so I could do 2 and 36. All right, let me pull a stick. I want somebody to break down 36 for me. Here, Mr. Alcama. 36.
12.
12 what? 12 goes into 36. How many times?
2.
No, that's 24.
I know.
Mr. Orweller?
3 times.
Yeah, 3 times. So I could do 3 and 12. Mr. Alcom, can I break down the 3 anymore?
No.
No. How about the 12?
Yes, you can break it down. 2 and 6.
2 and 6. Can I break down the 2? What? 3 and 2 and 3. Okay. I always list the smallest. factor first. Kind of hard to get into. So, how many 2's do we have here? 1, 2, 3.
3.
So it's 2 to the third times what?
2.
Times what?
3 squared.
3 squared. Okay, now, look at the numbers that we have here. I see a 2 here that matches and a 2 here. Which is smaller? The first one is 2, so we'll put that down, times. And then I see a 3 here and a 3 here. They're the same. What's 3 squared equal?
6.
What is it?
9.
9. What's 2 times 9 equal? 18. So the greatest common factor between 18 and 72 is 18. Okay? Let me do, so I did number 2 there. Let me do number 4. I think that'll be the last one I'll do. All right, so number 4. So number 4, what do we have here? 145. 6 there. Mr. Lasore, which 4 do you want to break down?
45.
Okay. 5 and 9. Can we do anything with the 5? How about the 9? So what's the factorization of 45? How would I write it? Nicely. Okay. Mr. Rainbow, break down 20 for me. What 2 numbers go into 20? 4 and 5. Okay. Can I break down the 4? What is it? Good. Can I break down the 5?
Yes.
No. So I would write 2 what? Mr. Rainbow? Yep. 2 squared times what? Nicely done. So there we have it. Now, let's take a look. Do they both have 2's? No. Do they both have 5's? They each have a 5. All right. So, now this is important. This is where some students get confused. They each have just one number. And so the greatest common factor is 5. You don't multiply those 2 together. You wouldn't multiply the 2 5's together, because what's 5 times 5? Is 25 going to fit into 20? No, obviously it's not going to work. Not going to work. What, honey? Wouldn't even fit evenly into the 45. That's right. Okay. All right, so let's take a look here. Here's what I want you guys to do. How are we doing on time here? Oh, you guys got plenty of time. I suppose I could do another one. Yeah, let me do one more. I'm going to do number 6, you guys. Because that one has, whoops, what did I do? There we go. I'm going to do number 6. And number 6 has 3 numbers. Okay? It has 3 numbers. And you will have problems where they're asking you to find the greatest common factor for 3 numbers. So this is going to be an example of one. All right? So let me, let's see here. I can erase this and give myself some room. And if you're not writing this stuff down, I think that's a mistake, because Some of the problems that I do, I assign. And so now you're missing out on the answers. So anyways, I'm doing number 6 here. And it's 45, 75, and 120. So we're going to do it just like we've been doing the rest of these. Let me pull a stick here. Miss Russell, break down 45 for me. What two numbers go into 45? It ends in a 0, 45 ends in a 5, and something is divided, can be divided by 5 if it ends in a 0 or a 5. So you know it's going to be a 5. A 5 times what?
5 and 9.
Yeah, 5 and 9. Nicely done. Can we break down the 5?
No.
Nope. How about the 9?
3 and 3.
Yep. So what would that be? How would I write those? It'd be 3 squared times what?
Times 5.
Nicely done. Okay. Put up 10 points. Mr. Orweller, can you break down 75 for me?
5 and 15.
5 and 15. So let's see if he's right. What's 15 plus 15?
30.
30. What's 30 doubled?
60.
What's 60 plus 15?
75.
Nicely done. Okay. It works. Okay. Mr. Orweller, can I do anything with the 5?
No.
How about the 15?
Yes.
What?
5 times 3.
So 3 and 5. I always put the smaller number first. So, Mr. Orweller, we're done here. How do I write the factors of 75?
So there's 1 3 and 2 5.
And so how would I write that, the two 5s?
3 and times 5 over 1.
3 times 5 what?
5 squared.
5 squared. Nicely done. Put up 10 points. All right, 120. Last one. We'll break that down. Mr. Catania.
Okay. 16, 2.
What's that?
16, 2.
Okay, 2 and 60.
And 30, 60 would be 2 and 30.
2 and 30.
And 30 would be 3 and 10.
3 and 10.
10 would be 5 and 2.
And I always put the smaller number first, 5 and 2. Nicely done. How many 2's do we have here?
3.
So it'd be what?
2 to the power of 3.
Nice. Times what?
Times 2 times 5.
So we have 2 numbers left. So what's the next number I would write?
3, not 2. 2.
3.
3,
Okay. Times what?
5.
Nice. So there we have all of our factors listed. We have 3 squared times 5. We have 3 times 5 squared. And we have 2 cubed times 3 times 5. Now we need to find matches.
They all have
So they all have what?
3s.
There's some 3s, you're right, and a 3.
5.
Okay. And they all have a what?
5. That's their.
There's a 5, and there's a 5, and there's a 5. But they don't all have the 2's. So let's look. So what's the smallest 3? Is it, which one would I use? The 3 squared or the 3?
3.
Yeah, just a 3 times. And then what's the smallest 5 that matches?
5.
Just 5. What's 3 times 5 equal?
15.
So the greatest common factor for 45, 75, and 120 equals 15. You guys starting to understand this a little better now?
Yeah.
Good, I hope so, because that was a 20-minute video. That's a long video. All right. So here's what I want you guys to do. I want you to do, and I'll highlight them in what color?
Teal. Yellow. Yellow.
We'll do yellow. So do 1, actually 1, 2, and 3, 4, 5, and 6. And oh, where's my, there it is. And then I want you to do whoops, do 4 over here and 6, 8, 10, and 12. And then we'll jump on the rest next week. So those problems right there are the ones that I want you to do. And
So you only want us to do 4, 6, 8, 10, and 12?
thank you. What's that?
You only want us to do 4, 6, 8, 10, and 12?
So what, let me write this down here so we can all be on the same page here. What page is this on?
34.
So page 34, you said?
Yeah.
Do 4, 6, 8, 10, 12. And then, what page is this right here? What are these on? What is it?
32.
Page 32?
Yeah.
And that's 1 through 6. Okay, page 32. Page 32, numbers 1 through 6. And I did some of them already. So there you go. That's your work. And you guys got 15, 20 minutes to work on this right now. It shouldn't take you too terribly long. I'm going to end this video right here.